Hello everyone, welcome to our presentation for our Csc645 group project. Today, we are thrilled to introduce our project named Advanced Routing System for Nasi Ayam Gepok. We wanted to take a classic computer science concept, graph algorithms, and apply it to a real-world, high-stakes problem ensuring local food delivery stays piping hot. Before we dive into the dataset, let me introduce the minds behind the project. First, we have Muhammad Zul Hakimi, our project leader and a systems analyst who identified and defined our core real-life traffic problem in Matang Jaya. Next is myself, Ishraf Jazli, our lead developer and algorithm designer who built our dynamic graph and logic and implemented the priority queue Dijkstra algorithm inside Java using BlueJ. And finally is Azizi, handling multimedia and quality assurance, validating our route calculations and managing our presentation media. So moving on, let us talk about the core issue we are trying to solve. Imagine ordering a fresh, crispy plate of nasi ayam gepok from Depot Kitchen HQ in the Matang area of Kuching. You expect it to arrive hot, right? Unfortunately, local food delivery faces a massive logistical challenge. Here is what happened in reality. Delivery riders constantly get stuck at the heavily congested Jalan Hubung Matang Jaya and Jalan Depot intersections during peak hours. Secondly, if they rely on standard mappings apps, the app will blindly suggest the absolute shortest geographical distance, completely ignoring sudden spikes in traffic volume. The frustrating result is delayed deliveries, wasted fuel costs, and most importantly, dissatisfied customer receiving cold meals. We realized that the standard static routing just doesn't cut it. We needed a system that adapts the environment dynamically.
Hi, and my name is Maman Suhakini bin Maman Sukadi. I'll be presenting on my part, which is mathematical graph modeling. We have five vertices, which is Depot Kitchen, Taman Matang Jaya, Metro City, Kampung Gita, and Taman Liling. Edges represent the physical road connection between the residential area and the commercial hubs in the Matang district. Dynamic weight based on travel time in minutes multiplied by the live traffic condition. For example, 1.0 for clear, 1.5 for moderate, and 2.5 for heavy. Moving on to the solution, we'll be using the Dijkstra algorithm plus priority queue. Instead of a standard agency matrix, we utilize an agency list paired with a mean heap priority queue. This allows the system to instantly adapt to traffic multiplier. Example, routing through Kampung Kita if the main Matang Jaya road is congested. By extracting the minimum distance not iteratively, the algorithm will relax connecting edges and guarantee the absolute fastest route. Based on the feature given in the slide, as you can see, we'll be using rescue source to the depot, to the Matang Jaya Road, and to Kampung Kita to Peta Jaya, which is our target. We'll be using the smallest and the shortest, since the red one indicates that it has a congested or heavy traffic, while the yellow one shows that it's a clear road. Moving on to algorithm complexity, we're using O bracket E dot log V close bracket, which optimize for speed. Using a standard matrix, the Dijkstra OV power 2 runs in a 4 dense real world road network. This is too slow. By implementing a priority queue, extracting the minimum node take logarithmic time, reducing our worst case time complexity drastically. This ensures our apps run seamlessly on a rider mobile device without delay.
My name is Azizi Winostan, and let's move on to the system architecture that we are using in the BlueJ. The first one is the delivery network. So the core logic engine contains the inner classes for root and node, and executes the dynamic priority queue relaxation. Second one is delivery graph, the fallback structure showcasing the algorithm utilizing and standard agency metrics for base level theoretical comparison. Third one is delivery app, the main simulation driver instantiates the graph, injects realistic traffic, multiplies data, and executes optimal dispatch routine. So, by replacing a human guesswork with the exact mathematical logic, we ensure that the food arrives hot, riders stay safe, and fuel is safe. So, this is the advanced routing system objective. So, thank you for listening, madam, and that's all from my team, and thank you.